The last kind of problem we're going to look at to work in terms of solving trig equations is something like this. So let me take a minute and point out to you some things that are important, and it's going to impact the way we go about solving this equation. First of all, we're going to have problems like this where we're solving for theta, and they're going to want the general solution. So I still have my notes here from some of the other videos. So when we first started solving trig equations, like this problem, we talked about finding the general solution, right? And the general solution for, in this case, the sine was where you have to add 2 pi k. You take one trip around unit circle and you add 2 pi k to both your solutions. So that's what we're going to do here. But the big thing that's going to make this problem more difficult to solve and involve extra work is, let's look inside the trig function. You notice inside the trig function is 2 times theta. If I have my old notes here, if I just grab all the problems we've done where we've solved trig equations, and you look at all the trig functions, look here, sine of theta. I'll just grab a few more. How about this one? Began cosine squared of theta, but inside the trig function is theta. Here was a problem we did. Cotangent of theta minus square root of 3 equals 0, but look at the trig function. It's theta inside. Here's another one we did. So up until now, every trig function we solved, the trig function had a theta inside. Well, now we're going to do some problems where inside the trig function it's not simply theta, but there's going to be some other stuff. Like here we have 2 times theta. And because of that, there's some more stuff involved. And let me say this first problem, and in the homework you're going to be asked to give this general solution, but there are going to be problems later on where you're asked to give the specific solution, where you're asked to give the solutions for the angles between 0 and 2 pi. But let me warn you, even when you're not asked for the general solution, with these kinds of problems, the only way to get the correct answer is you still have to find the general solutions as like an intermediate step. The general solution is not going to be your final answer, but to get the correct final answer, you have to first come up with the general solution. So we will do one of those kinds of problems later on, but just to warn you, now we're going to be working with these general solutions all the time. So I think the best way to try and explain this, what if we were given this equation to solve? Cosine of theta equals negative square root of 2 over 2. So now we're back to sort of what we're used to. And if we were to take one trip around the unit circle, negative square root of 2 over 2 occurs at 3 pi over 4. For the general solution, add the 2 pi over k, and also at 5 pi over 4. So here are my 2 general solutions for this. What I want to do is, here I have 2 theta. I want to sort of initially not even think of what's inside the trig function. I just want to sort of say the cosine of what equals negative square root of 2 over 2. In other words, hopefully you can understand what I'm going to be getting at. initially, I think the best way to solve this is to sort of ignore that I have a lot of stuff other than theta inside the trig function. And I just want to say to myself, what would be the angle where the cosine is negative square root 2? And what I'm going to do is I'm going to write that answer here. I know for the unit circle, the cosine of 3 pi over 4 plus 2 pi k, this angle, the cosine of this angle is going to be square root of 2 over 2, and there's a second angle so it's almost like I sort of initially ignore what's inside the cosine and I say the cosine of what is going to equal negative square root of 2 over 2. 3 pi over 4, 5 pi over 4. But then what I do is once I figure these out, I come here and then I move this down into my solutions. In other words, initially I'm looking for the angles where the cosine of something is negative square root of 2 over 2, and those angles are 3 pi over 4 and 5 pi over 4. And then once I find my angles, I go ahead and now take what's inside the cosine function and just place it here. Hopefully you sort of see that and you can do it. May not make a lot of sense at first, but I think that's the easiest way to go about solving these kinds of problems. And we'll do a couple more and you'll hopefully get the hang of it, and it's a useful tool to solve these kinds of problems. So now, of course, my ultimate goal for this is to solve for theta. I have these two equations. Of course, right now, it's 2 theta. So for this equation and this equation, I need to divide. Let's just do it like this so it's clear. The first solution is 3 pi over 4 plus 2 pi k. Now to get rid of this, I can divide both sides by 2, or another way to think about it is you can multiply both sides by a half. That's the same thing. I might actually multiply by a half because it may make the math a little bit simpler to see. So dividing by 2 or multiplying by a half, you're doing the same thing. So on the left-hand side, I now have theta, which is what I want. Now, a half times this is going to be 3 pi over 8. And then 1/2 times 2 pi over k is just going to be pi over k. Now for my second solution, I have to do the same thing. So my second solution comes from this equation, 2 theta equals 5 pi over 4 plus 2 pi k. If I want theta by itself, I'm going to do the same thing, multiply both sides by 1/2. So over here I get theta equals 1/2 times 5 pi over 4 is 5 pi over 8. 1/2 times 2 pi k is just pi k. So now these are my two general solutions for this. And if I look at the homework problem I'm working on, it's right here. It says give a general formula for the solutions. So I could go here and write in, let me look at it again, it's 3 pi over 8 and 5 pi over 8. So the smaller angle is 3 pi over 8 plus pi k. And then the larger angle is 5 pi over 8 plus pi k. But then, up here in the instructions say list 6 solutions. So then down here, there's one more answer box, and they want you to list the first 6 solutions greater than or equal to 0. So this is what you've done before when you had to solve equations and give a general solution. So just to finish this problem, here are my 2 general equations. So remember what I do? I usually go here and I make a column for k and then a column for theta. And we start by setting 0 equal to k. So for this first general solution, when k is 0, my solution is 3 pi over 8. Now I go to the second general solution when I put in 0 for k, 5 pi over 8. Now, if I set k equal to 1, now I have pi plus 3 pi over 8. Well, I change pi to 8 pi over 8. When you do that, you get 11 pi over 8. Over here, 8 pi over 8 plus 5 pi over 8 is 13 pi over 8. So now I have 4 solutions. They asked for 6. So I set k equal to 2. So 2 pi plus 3 pi over 8, 2 pi is the same thing as 16 pi over 8. So 16 plus 3 is 19 pi over 8. And 16 pi plus 5 is 21 pi over 8. So then these would be the 6 solutions, the first 6 solutions to this equation. So the whole key is here, understanding this step here where you go find your angles, and then after you find your angles, you plug in whatever's inside the trig function. So let's look at another problem. For this one, I may not finish it, but I'll do the initial setup because that's the new thing that we're learning. So this one is sine of theta over 2 equals negative square root of 3 over 2. So once again, so this problem is, once again, they're asking for the general solution, and then they're asking for the first 6 values. I may not finish it, we'll see. But the key is, I notice right away inside my sine function, it's not just theta. It's theta over 2. So what you do is, once again, I sort of think to myself, well, let me think of the unit circle. If I'm looking for the sine of something that equals negative square root of 3 over 2, I'm looking at unit circle. What are the angles where the sine is negative square root of 3 over 2? Down here, 4 pi over 3 and 5 pi over 3. So I sort of say I'm going to have 2 general solutions, 4 pi over 3 plus 2 pi k, and 5 pi over 3 plus 2 pi k. And now I bring down whatever is inside the trig function. So now I have these 2 equations. If I get theta by itself, then I will have the general solutions. Now for this one, since I have theta over 2, if I multiply both sides by 2, then I should have 8 pi over 3 plus 4 pi k. And for this one, I'll have 10 pi over 3 plus 4 pi k. So there are the two general solutions. They ask you for the first 6 solutions. You would set up the table and plug in k equals 0, k equals 1, k equals 2, and go from there. All right, so those are both questions you'll have where they want you to give the general solution. So here's what's interesting. Let me do this one. Cosine 2 theta minus pi over 2 equals 1. We want to solve for theta. Of course, here now they say, but just give the solutions between 0 and 2 pi. Now here's the danger. Back before we were solving equations, and they asked for, like this problem, when they asked for the solutions between 0 and 2 pi, we solved for the trig function, and we got down to here, and then we just simply took one trip around the unit circle and got our answers. Let me look, maybe another problem we did. We did this one. 2 sine of theta plus 4 equals 3, and they were asking for the solutions between 0 and 2 pi. So we solved for the trig function, sine of theta equals -1/2, and then we simply said, let's take one trip around the unit circle, and we found 2 angles and we were done. You cannot do that here. Even though they're saying look for the angles, look for the solutions between 0 and 2 pi. To do this correctly, you have to go ahead and find the general solutions. And then once you find the general solutions, you can go about finding the angles between 0 and 2 pi. There's no shortcut. You can't just go around the unit circle and assume those are the correct answers. So therefore, we're going to do what we've done lately. I sort of ignore initially what's inside and ask myself, looking at the unit circle, what's the angle where the cosine is 1? Well, the cosine is 1 at the angle of 0. And I could put, let's go ahead. So once again, even though I'm looking at 0 and 2 pi, just to be safe, well, I don't need to put this 2 pi here, because when k is 1, that equals 2 pi. So there's actually, for this one, for the unit circle, what's the angle where the cosine's 1? It's just angle 0 plus 2k pi. But I should not have done this here. I don't want to put theta there. Instead, I just want to put my angle here. And then, on the left-hand side, I want to bring down this is pretty messy. Let me rewrite it. Of course, normally when you have 0, you don't write it 0. So really what I have here is this is the general solution to this initial equation. Let me step through it again. So when I have all this stuff inside the trig function, I sort of ignore it and I ask myself, what's the angle where the cosine is 1? And I said 0 plus 2k pi, the general solution. Once I found this angle, and there's only one angle for this problem, then you bring down all the stuff inside the trig function. So that's how we get here. Now once I'm here, I do want to solve for theta. I want to get theta by itself. First thing I have to do is I have to add pi over 2 to both sides. And now to get theta by itself, I'm going to go ahead and do what I did before and multiply both sides by 1/2. So 1/2 times 2k pi is just k pi. 1/2 times pi over 2 is pi over 4. So here is my general solution. Now for this problem, they're asking me what are the solutions between 0 and 2 pi. So this general solution is now what I'm going to use, and I'm going to start plugging in values of k and see how many angles are between 0 and 2 pi. So if I go over here and set up my table, let's start with k0. When k is 0, theta is pi over 4. Pi over 4 is between 0 and 2 pi, so that's going to be a solution. How about when k is 1? So it's pi plus pi over 4, and that's actually 5 pi over 4. And that's between 0 and 2 pi, so there's a second solution. Now this is something you have to do, and normally it doesn't amount to anything, but occasionally it does. You remember way back when we did general solutions, we said k can be like -2, -1, 0, 1, 2. Normally we just sometimes plug in positive numbers for k, but occasionally there may be a problem where you need to plug in a negative number for k. So let's just, for fun, see what happens if I plug in k equals -1. So I have negative pi plus pi over 4, which is -3 pi over 4. Now we're wanting the answers, the angles, to be between 0 and 2 pi, so this just confirms that I don't need to worry about the negative k's. Now what I need to keep doing is I need to keep increasing my k's until I get outside of 0 to 2 pi. When k was 1, it's 5 pi over 4. Well, what about when k is 2? Well, when k is 2, I have 2 pi plus pi over 4. Now, it should be pretty obvious now that it's going to be larger than 2 pi, although I'll go ahead and write it here. 2 pi plus pi over 4 is 9 pi over 4. Now 9 pi over 4 is larger than 2 pi, so it's outside of where we're looking. So there are actually going to be two solutions, pi over 4 and 5 pi over 4. Now if you wanted to, just like when you were solving equations in algebra, I should be able to take pi over 4 and plug it in here for theta, and if I do the math here, the left side should equal 1. And the same thing for pi over 4. Now let me just look at one more that I will just set it up so these are a little tricky. This last one I will work is sine of 2 theta. So once again, I've got more than just theta inside the trig function, so I have to account for that. Even though this one, they're saying I want the angles between 0 and 2 pi. Even though they say that, I am still going to have to find my general solutions. To get the correct answer, you still have to first work the general solution. So let's do the thing where I say, okay, let's go find in the unit circle whatever angles the sine is negative 1/2. And it's going to be, we'll check this in a minute. I'm pretty sure from memory, 7 pi over 6 and also 11 pi over 6. So we're looking for a sine of negative 1/2. 7 pi over 6 and 11 pi over 6. But now you bring down the 2 theta to form your equation. If I want to solve for theta, multiply both sides by 1/2. So this is going to be 7 pi over 12 plus pi k, and 11 pi over 12 plus pi k. So those are the two general solutions. I'm not going to finish this problem, but to finish this problem, you would start plugging in numbers for k into each of these general solutions, and then you would keep increasing k until these angles increased or were larger than 2 pi, then you would stop. I guess if you guys want to quit watching, you can. I guess I can finish this just if you're interested. So for 0, it'll have 7 pi over 12 and 11 pi over 12. If k is 1, pi plus 7, that's like 12 pi. It's like 19 pi over 12. And if you were at 12, it's like 23 pi over 12. Now when I set k equal to 2, I'm going to be adding 2 pi to this. Well, hopefully you can see that obviously it's going to be larger than 2 pi. So really, those should be the 4 solutions for that problem. And I'll check to make sure I didn't make any math errors, and that looks correct. Okay, so that's how we deal with trig equations where we have something different than theta inside the trig function.